All right, so what we're gonna do is what we're gonna do is if you miss the Friday test, that test will help you grade change your grade for that one chapter 3 test. If some of you guys misunderstand, like Alex mess up understanding f prime of x and f of x graph, hopefully you didn't mess up this time. Um, and if you need to take it, you must take it today because I'm gonna have them graded. Um, did you anybody miss the test Friday before the break? No. Josephine show up. I feel like you've been absent a lot. Mm-hmm. Mm-hmm. No, it missed like 3 days after the debate. 2 days. There you go. So it's average between my prediction and your prediction. All right. So I'm gonna start by asking you, what do you know about integrals? Raise your hand if you think you know anything about integrals. Okay, Alex. Yeah. Okay. Anybody else? You are absolutely right. Anybody else like to add? No. Is it good? When you take the integral, one thing you cannot forget is the plus c. Okay, plus c is very, very important. And just say, if is example, if I have a 10-point questions, then if I without plus c is a simple things that you have to do, then you would get it wrong, right? No, you'll get half the point off, so it'll be 5 points off. But if every question is 5 points off, then that's half the grade. So there's a certain thing that you have to make sure you do, which especially is something called indefinite integral. So we're gonna start by the talk about something. We're gonna start by talking about what we learned before the break. Before the break, we learned about derivative, all the derivative operations, all the things, and you say, okay, well, today, what if you have a dy dx is equal to 2? Okay, dy dx is equal to 2. Now, here's my question. Dy dx is the slope. What do you think original function is? Cameron? 2x. Yeah. Why? Because derivative of 2x is 2. Does that make sense? So y must equal to 2x. But that's not entirely right. Because what if it's 2x plus 1? What's derivative of 2x plus 1? 2. What's derivative of 2x plus 10? 2. 2x plus 20. 2, right? So it must have this, it's called constant of integration. Now, at first, you're going to say, well, that doesn't make sense as of right now. Later, I'm going to show you visually what does that make sense. But this is called constant of integration. The operation from here to here is the inverse operation. What Alex says, it sounds very intelligent when it says inverse operation of the derivative. It is correct because this is called an antiderivative. Or it's called indefinite integrations. So integral is interchangeable with the antiderivative. Now, what is this called though? This has a name. If I just show you the dy dx or f prime of x, this is called a differential equation. Differential equation. That's before before you integral the dy dx or f prime of x. That's the differential equation. So if I ever show you that says dy dx or y prime or f prime of x, those are all differential equations. Because we didn't give you an equation, we give you a different after you take a derivative. Does that make sense? First notation goes that if you integrate of f prime of x dx, it will give you a f of x plus c. Do you see that there is a notation difference? It was, sorry, my fault. This one is capital F. If I have f prime x, if I take an integral, it's going to be capital F of x dx. Okay, let's talk about all the rules. There's not many rules for integrations. It's a lot less than derivative, and that makes integration a lot easier. So let's talk about all the rules, but start with talking about derivative. If today the derivative is d to the dx of a constant is equal to 0, is that okay? So what's integration of 0 dx is equal to what? C. Integration of kx, derivative of kx is equal to what? What's the derivative of kx? Okay. What's the integration of k dx? If integration of a number? No. Not k plus c. Huh? Kx plus c. Just by understanding this, you probably won't mess up the first question of the homework. And I will say 60% of students will mess up the first question of the homework today. I promise you, 60%. D to the dx of k of f of x. Well, this one just take the k outside and take a derivative of that, so it'll be k f prime of x. Is that okay? Integration of k f of x dx. Again, you can take the k outside and just focus on the integration of the inside. Very simple rule. I'm almost done. I'm going to 2 more rules to talk about. D to the dx of f of x plus minus g of x is called sum and difference rule. It's going to be f prime of x plus minus g prime of x. So that means integration of f of x plus minus g of x dx, which is integration of f of x dx plus minus integration of g of x dx. This is also very useful rules. All those rules are very, very useful. Lastly, what's derivative of x to the n? What's derivative of x to the n? Samantha? What's derivative of x to the n? Well, why don't you say it? So it's wrong, we're just gonna make fun of you. That's it. It's not a big deal. I think it's a lot of people are so embarrassed being wrong, and okay, there's a difference of being wrong and or being wrong. Um, so my older son, like he just doesn't process. He doesn't process. He doesn't process. If you ask him something, he doesn't process. He just blow out the answer, and that is doesn't have process. That wrong answer is bad. Um, and so a long time I taken to teach him says wait a little bit before you process. But once you process your answer is wrong, then you say it. It's wrong, and just fix it. Um, but process first though. Process. Okay, so what's the right answer? And if you go through the process, like a lot of times, like we skip the processing part, and and for example, your first question on your homework, you'll mess up because you don't process. Hopefully, you don't mess up. Integration of x to the n and x to the. Okay, so what's integration of this though? This is the rule that we need to talk about today. It's the most important rule, which as we know is a power rule. So what's integration of x to the n? Like, how would I take an integration x to the 5, right? What will be the rules that you can establish that think about integration of x to the 5? What derivative is going to give you x to the 5? Yes?
5x to the 4 plus c.
No. Yeah, you're talking about derivative. I'm talking about which function, if you take a derivative. Yeah, which function you take a derivative is going to be x to the 5. 1 6 x to the 6. Good job. But you're going to be like, how does that work, right? So, well, it's basically x to the n plus 1 over n plus 1 plus c. Well, why that is? Imagine that if you take a derivative of x to the n plus 1 over n plus 1. Guess what? If you take a derivative, like using the power rule, it's going to be this one is going to fall in the front, right? And going to subtract by 1. So it'll be n plus 1 over n plus 1 times x to the n plus 1 minus 1. So that's equal to x to the n. Does that make sense? So therefore, this rule is becoming the most important rule in terms of integration. And there's only one rule. So one rule, there is no other rule. There's no power rule. There's no chain rule. There's no quotient rule. There's no product rule. There's no chain rule. This is the only rule I apply, which is the power rule. And this is the only thing that's really matter today. If the integration x to the n is equal to x to the n plus 1 over n plus 1. And you're going to be like, well, that's it? Yeah, that's it. There's no other rules. But even this rule is going to give you henceforth because you have to know your algebra skill. So let's talk about algebra skill. Algebra skill exponent rule is a to the m times a to the n equal to a to the m plus n. A to the m over a to the n equal to a to the m minus n. It's top minus bottom. You're gonna feel like you use those rules more than the power rule. I promise you're gonna use those rules more than power rule. Third rule is anything to the 0 is equal to 1. The fourth rule is a to the m. Sorry, this is the most important rule. a to the negative n equal to 1 over a to the n, or 1 over a to the negative n equal to a to the n over 1. The fifth rule is not that important. So the fifth rule is going to be a to the m to the n power is equal to a to the m times n. And the sixth rule is very, very important. Is a m to the n equal to a to the m over n. Now, you know this since algebra 1. You know this since algebra 1. You're going to find out you use the algebra 1 skill more than you use calculus skill, because calculus skill is only one line. Okay, let's start first. Let's take an integration of 3x dx. How do I take an integration of 3x dx? First of all, I would like to take the 3 outside because it's constant. So integration of x to the 1 dx. What's the integration of 1? X to the 1. What's the integration of that? Huh? 1. No. What's the integration of x to the 1? No. What? X squared over 2. Because you're using the power rule. X to the 1. So it'll be 3 times x to the 1 plus 1 over 1 plus 1, right? Now, do we forget something? Plus c. Now, c is there. It's very, very important. So that's going to be 3x squared over 2 plus c. Does that make sense? Is this okay? Okay, I'll just ask you to take integration of this. Actually, this is 3. Okay, I'm going to ask you to take integration of this. But remember, the rule of the power rule, this is our numerator. It's our numerator. It's x to the n. It's not 1 over x to the n. So as far as right now, you can apply this rule. You have to apply the rule if it's on the x squared is on the numerator, but you have to do something else to make it become numerator, right? Okay, so obviously, as of right now, I cannot use power rule. So we need to use all the exponent rule. For example, number 4, we can change to the top. Is that okay? So integration of 3x to the negative 2 dx. Did you do that? Because now I can use the power rule. So the power rule is going to apply. So we can take a 3 outside. So 3 times x to the negative 1, because it's a negative 2 plus 1 over negative 2 plus 1, right? So be 3x to the negative 1 over negative 1 plus c. Is that okay? So be negative 3 over x plus c. How many you guys got it wrong? Okay, Stefano.
Still trying to understand this whole concept.
Okay, Stefano, what are you confused about?
For some reason, it's not the things aren't getting into my head.
Max, you got it right?
No.
Okay, do you know why you did it wrong?
I don't think I took the power rule correctly. I got up to the point where
3x to the negative 2?
I got it to that point.
Okay, so you just have to do a power rule. So the power is going to be negative 2 plus 1 over negative 2 plus 1. Let's try again. Okay, let's try this again. Okay. How many guys are done? Done? 10 minutes done? You don't get it? Okay. First of all, using the exponent rules, this rule here. So that is equal to integration of 4 over x to 3 over 2. Does that make sense? Yeah. And then 4, if you want to move to the numerator in order to take an integral, 3 over 2 negative dx plus c. Is that not plus c, right? Yeah. So now I'm going to integrate this. So be 4 to the x to the negative 3 over 2 plus 1 over negative 3 over 2 plus 1 plus c. Are we okay here? Yeah. So that's equal to 4x to the negative 1/2 over negative 1/2 plus c. Now, if you over this, it's going to keep change flip. So this one becomes 4 times 2 over negative 1 x to the negative 1/2 plus c. So it'll be negative 8x to the negative 1/2 plus c. Is that okay? Stefano is still confused?
Yeah.
I basically get to this part. I'm gonna integrate the x to the negative 3 over 2. It's gonna be x to the negative 3 over 2 plus 1 over negative 3 over 2 plus 1 using the power rule. Yes. Can you leave what in fraction? Here? No. Oh, you can leave it like this? Yeah, you can leave like this, or you can leave like this. You can, that's fine. Either answer is acceptable. How about integration of x plus 2 square dx? Now again, we only know how to use power rule and sum and difference rule. So what can I do with this one? What can I do with this one? I can expand it. Yeah, of course. Any algebra stuff is fun. So be x plus 2 times x plus 2, right? And that expanded is going to be x squared plus 2x plus 2x. So it's plus 4x plus 4 dx. And that's equal to x cubed over 3, because that's 2 plus 1, plus 4x to the square over 2, plus 4x plus c. Sorry, did I plus c? I didn't forget plus c. Okay. So that's equal to x cubed over 3 plus 2x squared plus 4x plus c. Is this okay? I didn't do anything crazy. I didn't do anything crazy. I just did the things I know what you would do. You can try again. Yeah. Because integration of 4 is 4x. So you can try to take integration of this one. Okay. Definitely you know how to do it?
I think I got it.
Okay, so it'll be 9x squared if I expand them. Plus 6 minus 6x, is that right? No, minus 12x, sorry. Plus 4 dx. Is that okay? It's gonna be 9x3 over 3 minus 12x squared over 2 plus 4x plus c.
I get the 9x, I get plus 4, I'll get the...
2 plus 1 is 3. So it'll be 3x squared, or 3x cubed, sorry, minus 6x squared
Oh.
plus 4x plus c. Is that okay? Okay, so
Okay.
remember, there's no product rule.
Silly me.
There's no chain rule. There is no there is no quotient rule. So the key thing is there's no quotient rule.
Wait for the catch.
So there's no quotient rule here. How would I take integration of this? Yeah, we're doing this. There's no quotient rule, there's no product rule, there's no chain rule. How do we do this? If you know how to take a derivative of this one, you know how to take integration. Okay, so if what should I do first? Split up. Thank you. People mentioned about splitting. Yes, I will split this because I can't really do quotient rule. And even if I do quotient rule, I would prefer not to do quotient rule because those are things I told you since the very beginning. This one is gonna split. This one's 1/2 plus 4x to the 1/2 plus 5x to 5 over x to the 1/2 dx. So if I simplify this using the exponent rules, is going to be x to the 3 over 2 plus 4x to the 1/2 minus 5x to the negative 1/2 dx. Is that okay? I didn't take integration yet. The only part I'm going to take integration is this part. It's going to be x to the 3 over 2 plus 1. What's 3 over 2 plus 1? 5 over 2. And divided by 5 over 2, so I can change that because it becomes 2 over 5. Is that okay? Is that okay? Because I make my life easier because divided by 5 over 2 is 10 things times 2 over 5. Yeah. Plus 4x to the 3/2 times 2 over 3. Is that okay? Plus 5x to the 1/2 times 2 plus c. So it'll be 2 over 5 x to the 5 over 2 plus 8 over 3 x to 3 over 2 plus 10 x to the 1/2 plus c. Is that okay?
Yeah.
Never forget to see that. Okay. Yeah, I think I'm starting to get it now.
Is this okay? All right. I'll give you a try one more just in case.
Spanish again.
So far, are we okay? Have I did any calculus yet? No. That's why I said calculus is not difficult. It's the algebra is difficult. Is so far okay? I only did algebra. I didn't do any calculus at all. Now I'm gonna do calculus. The only line that calculus is right here, x to the 3 over 2. 4 times 2 over 3, right? Is that okay? Because divide 3 over 2 becomes 2 over 3. Is that okay? Plus x to the 1/2, 2, so it'll be 24. Is that okay? Plus 9x to the, this is the 1/2, this times -2, plus c. So that's 8 over 3, x to the 3 over 2, plus 24, x to the 1/2, minus 18, x to the -1/2, plus c. Is that okay?
Yeah.
Is this difficult?
Not really.
This is probably the hardest question, integration. As of right now, the indefinite integration that's possible. I can give it to you. Yes.
So like when you're taking that like 4 2 over 3rd x, like when you took that 3 over, like it was 3 over 2 like up here, but then we took it down as 2 over 3. Like I when you like you kind of explain how you did that, but like.
Okay, so I'll explain that again. So let's say 4x to the 1/2, right? This one's gonna be 4 to the x to the 1/2 plus 1, right? Over 1/2 plus 1. Is that okay? So 4x to 3 over 2, 3 over 2, right? Now when you divide, so that means 4x to 3 over 2 times, if you divide, can I say that's divide? So that just says, sorry, 4x to 3 over 2 divided by 3 over 2. if it's divided by 3 over 2, that means times 2 over 3, right? Keep change foot. And that's how you get 8 over 3 x to the 3 over 2. That's fine. That's a good question. Yeah. And that's it. It's just more algebra than calculus. That's a problem people struggle with calculus, is because their algebra is not there. Okay, so is this okay or no? Sydney, do you understand? Okay. You guys get it right or no? Good? Okay. So now we're gonna go back to talk about certain things. All this here. Hold on a second. This is known as a general solution. So if you have something plus c, that's a general solution. Now, why is general solution? Because now we need to go find out what c is. So, for example, I'm going to give you a question here that just say, hey, the dy dx is equal to 3x squared minus 1. And remember, this is the dy dx. Our goal is to find out what y is, y equal to, and also I'm going to give you some type of initial condition. What is initial condition? The function y must pass through point of 2 comma 4. So 2 comma 4. Why is 2 comma 4 is important? Because if you integrate it, let's try to integrate this. So if I have dy dx equal to 3x squared, how do I get to original function?
Well, you do the integral.
You do integral. So now I'm going to show you one more thing about taking integral for AP exam. It's going to be easy point for you to earn. And this point is called separation of variables. So what happened is, what is separation of variable? And the easy point we're going to talk about later as well. 3x squared minus 1. So I'd rather talk about right now is I can multiply by dx on both sides. So that dx on both sides, and that becomes dy equal to 3x squared minus 1 dx. Is that okay? I didn't do anything crazy. I didn't do anything crazy. I just know that I can move the dx to the other side. And what I'm going to do is I'm going to integrate both sides. What happened if you integrate dy? Well, that's just 1, right? But integrate dy, that's just going to give you y. Is that okay? Is that integration of x will be 1 dx will be x. But integration of dy is going to give me y. What's the integration of 3x squared? 3 times x cubed over 3, right? Minus x plus c. Do not forget plus c, because this c is super important. Because this c is super important here, especially for this question. So that's equal to y equal to x cubed minus x plus c. Now you're going to be like, well, why is that c important? Because we say the function y must pass through this point, 2 comma 4. What do you mean by 2 comma 4? Because when you integrate this, what will happen? We're going to show you this is an x cubed minus x plus c. Now, what does c look like? C look like some type of vertical translation. So do you see the c is changing? Any of those is going to give me a center derivative of 2 comma 4. So there was a point there, 2 comma 4. The only one time of the c where it's going to go through 2 comma 4. Do you see that? So this is a vertical translation. There's only one situation that'll go through that point. So now this is called particular solutions. Why is a particular solution? Then you can say, okay, well, just take this point and plug in here. So it'll be 4 equal to 2 to the third minus 2 plus c. So 4 is equal to 8 minus 2. And 4 is equal to 6 plus c. c is equal to -2. Then you can say, okay, well, the function becomes this. X cubed minus x minus 2. This is the only situation which is we know is a particular solution. Instead of general solution doesn't go through that point. Particular solution go through that point that you assign. So there's only one situation fit. There's only one c value that's going through that. Am I going too fast? Okay, I want you to try questions. What time we get off? Okay. So f prime of x equal to 1 over x squared. And what's f of 1 is equal to 0. I want you to figure out what its original function is, what's particular solution in this case. Now this you can look at as what? dy dx, right? And this one you can look at as 1 comma 0. So that means I have to integrate this, right? So if I integrate, there's going to be x to the -2 dx. That's going to be -1 over -1 plus c. Again, this is called a general solutions. It's not a particular solution. So f of x is equal to -1 over x plus c. I can plug in the f1 equal to 0. So that means 0 is equal to -1 over 1 plus c. c is equal to what? 1, right? So this one becomes -1 over x plus 1. Is this okay? Now we're going to talk about one last situation before you leave. The only thing that you had to do is this part. So this is the last situation. Let me talk about a little bit really quickly so you understand. I will give you a second derivative today's homework. The second derivative is 3x squared. And what happens if you take an integrate, this becomes f prime of x. Now you're going to have a plus c. There's an initial condition at -1 and -2. F of -1 equal to -2. That's going to give you a unique c for f prime of x. You're going to, based on the new c, write out new equation for f prime of x. You're going to have to integrate again to get the original functions. And then you're going to find out the second c. So there was a c1 and c2 you had to find. Okay, so this is one of the harder homework questions that you have to do. Unfortunately, I'm not able to get it. Hopefully, I'll make a video very quickly right now. So I'm still making this video. I'm going to show you how to do it. Okay, so you can watch the end of part of the video.
See you tomorrow.
Good, thank you.
What, two guys in the front? No, yeah, it's so sad. Not having to think about it. Yeah.
Oh, okay.
What's that?
What did you?
Monster.
Huh?
It's like we played that.
It's okay.
It is fun. It's just food and me, like I hear people all here. Yeah, bro. I will not yeah, my stupid was messed up. I don't know.
I hate the January part to the March because there's no break, there's no holiday, that's spring break. And it's a very long section, and also like daylight saving time as well. It's still later, and you wake up in the dark. Oh, great. Screen freeze.